particular set of problems is going to deal with the fourth item down, which is common factor, and then the second page is going to deal with the, if you look on down, I don't know what, I don't have it, but it down a ways there is a polynomial with 4 terms, and it's grouping. So it's those two parts of that algorithm sheet. And like I say, what we're doing is we're going to be studying things that you can do to solve problems. In this particular page, common factor is very important. If you miss the common factor, you will not be able to solve the problem. So in that algorithm sheet, it'll say expand the problem, get 0 by itself on one side of the equation, and then write it descending order, and then common factor it. And that's what this set of problems was about. So on 7.1, then I'm going to do number 2 first, and it has 7b minus 7. So what's common to those two? Each one of these is a term. So what's common to those two terms? 7. So you take the 7 out, and then you say what is left in the first term? A b. And what is left in the second term? 1. Because this is actually 7 times 1. So if you take the 7 out, you'll have a b for the first term and a 1 for the second. Because you've got to be able to multiply this and distribute it across here and get these problems. Okay? So then 8, 20b plus 5. Now the best way to do this is to prime factor your numerical coefficients. The 20 factors into 4 times 5, but it's actually then 2 squared times 5. And the second one factors into 5 times 1. Technically there's a 1 here also in the numerical coefficient. And then you say, what is common numerical coefficient, if any, in those two terms? This is one term. This whole thing. 20b is one term, and then 5 is the other. So what's common? 5 in the numerical coefficient is common, and that's all there is. So now what's left? Well, there's 4, which is actually this 2 squared. 4 what? B. And then in the second one, it's a 1. So that's prime factor. Now remember that you've got to be able to distribute the 5 across these two and get back to there. Those two. So let's look at 14. It says 6b cubed minus 5b squared. So what's common in those two factors? B what?
B squared.
B squared is common. So what's left after you take a b squared out of that term?
6b.
A 6 and 1b, right? What's common? What's left after that? Take that b squared out of there. A negative 5. So this is prime factor. Does that make sense? Now look at 16. 3y 4 minus 9y. Now I'm going to prime factor that 9. 9 is 3 squared. So what is common to those two terms?
16? Yeah.
16, yeah. What's common to those two factors? There's a 3, right, and a y. So what's left after you take a 3 and a y out of there? Y to the cubed, right? Y third. Because 3y times y cubed is y fourth. Now when I take a 3 and a y out of that second term, I'll have a negative. What's left? There's 2 3's in there. I'm taking 1 3 out, so I have a 3 left. I'm taking a y out. There's 1 y in, so that's what's left. Okay? So this is prime factor. (22) a squared b squared plus ab. What's common to the two? A times b, right? So what's left in the first term? AB, right? And what's left in the second? So what is it? It's 1. So it's a plus 1. Because what's understood is there's a 1 there, right? You take an AB out, you have a 1. Because to expand it, you got to be able to take this times this and get this times this one and get that. I'll do 24. It says 12a squared b5 minus 9ab. Now I'm going to take that 12 and I'm prime factoring. It's 2 squared because it's 4 times 3, isn't it? And the 9 is 3 squared. Now what's numerical coefficient? What's common? 1 3, right? So if 1 3 comes out. Now what's left in that first one in terms of numerical? Well, I better look at this. In terms of variables, what's common in this term? The A and B, right? So it's 3AB is common to the two. Now, what's left in the first one? There's a 2 squared, isn't there? Which is 4. So this is 4. I take 1A out, what's left? There were 2 A's, A squared, there's 2 A's. Took 1 out, so I just got to, I'm taking 1B out, and there's 5 of them. So what's left? B4. Now, I'm taking a 3 out, but there was 2 of them in here, so what's left? A3. And then I'm taking an AB out, so that's a factor. Now then it's switching to trinomials. And so you want to be able to factor a common factor out of your trinomials. We'll look at 28. 2x4 minus 4x cubed plus 6x squared. Now notice that's a trinomial descending order. Nice. So what is there a common numerical coefficient? A2 comes out, right? Is there a common variable? X what? Squared. Now, in the first term, what's left? An x squared. What would I have to take times this, what I took out, to get this term up here? I'd have to take it times x squared, right? Get 2x squared. So what's left in the second term? taking a 2 out, so there's going to be a negative 2. I'm taking an x squared out, so there's a what left? An x. Then it's a plus. I'm taking 2 out, so what's left? 2 times 3 is 6, so there's a 3. And I'm taking a squared out, so there's no variables left. You see that, Aaron? So that's completely factor. Common factor. I'll do 32. 2y fifth minus 3y4 plus 7y3. Notice every one of them numerical coefficients are prime numbers, right? 2, 3, and 5. So there's no common factor in terms of numerical coefficients. Now in terms of variables, what's common? Y to the third, right? So what's left after I take a y third out of 2y5?
2y squared.
2y squared. When I take a y third out of 3y4, it's what? Minus 3y. Be sure to get your sign in there. What's left on the last term? So it's a plus 7. That's the answer on that one. Everyone good? Okay, 34. It's an x cubed y minus 3x squared y squared plus 7xy cubed. Now notice numerical coefficients, there's nothing, right? So how about the x's? What's the largest x I can take out? There's an x cubed, x squared, x. So what can I take out? Just an x, right?
Just a 1.
And just a y. Everyone agree? Now, in the first term, what's left when I take one x and one y?
X squared.
An x squared. Second one, notice I have a minus 3. I'm taking an xy out. What do I have left?
2 minus 3x.
I got an xy, right? 3 minus 3xy. The last one, so plus 7. I can't get anything out of the numerical coefficient. So what's left after I take an xy? Y squared. Everyone with? Everyone good? So that's the answer there. 34. Let's do 38. 3a squared b squared minus 9ab squared plus 15b squared. Now, it might be beneficial, maybe not, to prime factor the numerical coefficients. That's prime. This one is a 3 squared. And this one is a 3 times 5. Now then I think it becomes obvious. What are you going to take out in the numerical coefficient? The 3. Now in terms of the variables, what are you taking out?
B.
B what?
B squared.
B squared, right? There's a squared in every one of those things. So what's left?
A squared.
An a squared of the first term, a minus 3a, and then a what? I've taken that 3 out, so what's left? Plus 5. And that should be my answer. Now notice 40 through 45 is variable exponents. These present a different kind of a problem. 40. X to the 2n minus x to the n. But you'll actually take an x to the n out. If you think about it, this right here. If I rewrite it, I can go x to the n squared, right? Multiplying, right? And then this is an x to the n. Now do you see the two terms? What do you got in common? 1x to the n, isn't it? So you could take an x to the n out, and then what would you have left in the first term? I've got an x to the n left, right? See, I had two of them right up there. I'm taking one out, so I have one left. Now in the second term, I'm taking this one out, so what's left? A 1. See, because if I take x to the n times x to the n, you can think of this in a couple of ways. You can write this thing right there. This one. You can write it as x to the n times x to the n, can't you? Base is the same, you add the exponents. That'd be x to the 2. And then minus x to the n. I'm taking one x to the n's out, and I have the other x n here, and I have a minus 1. You can think about that in either one of those two ways. Does that make sense? These are going to take a little bit of thinking to get it figured out. But now, if you notice, 42. If you think about this one, like I wrote it on the left-hand side up there. Write this one in this way. What would that first one be? X to the what? N to what? 3, isn't it? Isn't that right? 3 times n. And then this one would be what? X to the n times 2, isn't it? Now, what can you take out of those two? xn squared, right? And what would you have left in there? If you take two xn's out of this term, what would you have left? Just an xn. And if you take, this thing out of here, what do you have left? Minus 1. If you rewrite it in a form, there's a couple ways you can rewrite it, but that's the easiest way. Now, I just want to warn you, you can write this thing and this thing as this. You could write this one as x cubed to the nth power, and that would get you x3n, but it would do you no good, because you'd write this one as x2 to the nth power. Could be written that way, but it does you no good. You have to write it this way to make it worthwhile. See what I'm saying? You got to be able to think about how to write it. It's going to make it worthwhile to be able to use it to factor. Does that make sense? And that's why in the bottom of that algorithm sheet, remember, there's all those things that say powers of variables that you can use. So let's look at 44 and see what we can do with that to rewrite it, to make sense out of it, so that we can see what to factor out. That first term, when you add exponents, what can you write that out as? Could would you write this as a to the 2n times a squared? If the bases are the same, what do you do with the exponents? Add them. Is that right? And then the second term is a squared. Now can you see what comes out? An a squared. And then what's left for the first term? A to the 2n plus 1. See how if you use your rules of exponents, you can get that thing figured out. Now you might be able, some of you, after getting used to it, might be able to slip right down to there. I'm just showing you how to rewrite the thing so you can get it figured out. Now what I've done is I've done enough problems here. What you need to do is practice, and you need to look on both sides of the problems I did so you see how to do the odd problems that are similar to it, and then you can use the problem I did to try and figure out what it is. Like you can figure out, by using 44, you can figure out 45. By using 42, you can figure out 43. And 40, you can figure out 41. That's why I'm doing enough of the problem, so that you're getting a problem similar, but you're going to have to do the practice to be able to figure out, to be able to perform on a test, or you're going to have to practice. Now, next page. There's they've set this up in two different forms. 46 through 54 is a second step that you will get when you look at a problem 55 through 72. 55 through 72, if you just look at those problems, notice that there is a 4-term polynomial. 55 through 72 is like that number 6 or so, I don't know, on that algorithm sheet. It says if you have a polynomial with 4 terms, try groupings. This whole thing is grouping. And what you will see on an example of a problem, you will see 55 through 72 type problems. 46 through 54 is what your second step in grouping will look like. So you're going to practice these so that you can do the actual things. 46 says x times b plus 4 plus 3 times b plus 4. Now what you want to practice looking at is look at those two as individual terms. X times b plus 4 is one term. 3 times b plus 4 is the other term. Now, in those two terms that I underlined, what's common? B plus 4. So what you would do is you take b plus 4 out, and then what you will have left, in the first term that I underlined, you will have a what? X. In the second term that I underlined, you will have a 3. See, it looks as if you got a b plus 4. You know, you don't tend to look right off as it being x times b plus 4 as being a term, but it is a term. So then, considering that 46, let's look at 48. Kind of like this one, but a little bit different. So what's common? Is a y minus x common? Y minus x is common. Then it's what? A minus B. Now 50 is going to be a little bit different again. X times X minus 2 plus Y times 2 minus X. Now that X minus 2 and the 2 minus X are different by what? A sign, aren't they? So what I'm going to do is I'm going to put in a step here. I'm going to say that if I want to get this thing like this, I will have to take a minus sign out, and then this will become a minus 2 plus X, wouldn't it? So I could write this, and if I took this minus sign times that plus, I'd have a minus Y. And then if I interchange these two, I have an X minus 2, community property of addition, right? See what I've done? Taken the minus sign out, commute the addition, and now what's my common factor? X minus 2. And then I have what? X minus Y. So there's your answer. C 52. 2x times 7 plus b minus y times b plus 7. This is a term, that's a term. 7 plus b and b plus 7, are those the same? Yeah. So you can just take the b plus 7, you can take it out like this, because that's just commuting this. And then I have what? 2x minus y. Now, 55 through 72, this is the what you will actually see. And then the first problems will be the second step in what you, when you're doing this process. So I'm going to look at 56 first. 56. We have x squared minus 3x plus 4ax minus 12a. Now if you notice in your algorithm sheet, you go down there a ways, it says a polynomial with 4 terms. Is this a polynomial with 4 terms? Yes. What does it say? Try grouping. So this is what you will do. You will group the first two, and you will always add the grouped second 2 terms. Now then, you will take the first group and you say, what's in common in the first group? An x, isn't it? And now we have what? X minus 3. Now you go plus, and then you take the second group and what's common in the second group? An a will come out. How about the numerical coefficient? A 4 will come out. And what do you have left? An x minus 3. See, now we're just back to what the first few problems were, right? What we're going to consider this a term, and this a term, and what's in common? X minus 3, right? And then what do we have? X plus 4a. Right? Now what we're going to do is we're just going to make those problems a little bit harder by changing signs around and doing things. So 56, I'm going to look at 58. says t squared plus 4t minus st minus 4s. Now, once again, when you do an algorithm, it says polynomial with 4 terms, try grouping. So what are you going to do? Group the first 2 terms together. Then put a plus and put the second 2 terms with their signs inside the second group. Don't try to put a minus sign on the outside, because this is what you're going to end up doing. You're going to take that second group, you're going to put a minus sign, then you're going to go st, and you're going to go a minus 4s. And you see that's going to be wrong, because that, when you put the minus sign back through, makes it minus st plus 4s. See what I'm saying? If you try to just put the grouping sign in, like right like that, you will have a sign. You have changed one of the signs. You see what I'm saying? Don't do it. Always do it just like I said. Always put a plus sign in and put every term inside that bracket with its sign. Then work on common factors. Now, the first 2, what's the common factor? These 2. There's a common t, isn't there? So I take a t out, and I have a what? T plus 4. Now, with an I on my first one, I want to get a t plus 4. What am I going to take out of that second group?
S.
How about a minus s? Is that right? I'm going to take a minus s out, and then I'll have a what? A plus t plus 4. And you see, well, I've gotten it just like that. You see what I'm saying? You look at the second one and say, how can I make it look like what I want to take out of the first one? Now then, you look at this term and this term. What's common? T plus 4. So I'm going to go a t plus 4, and then what's left? That t, right? And then it's a minus s, right? And there it is. Okay, let's look at 62. It says 2y squared minus 10y plus 7xy minus 35x. Polynomial with 4 terms. We're going to try to group, right? We'll group the first 2 terms together. We'll put a plus sign. We'll group the second 2 terms together with their signs. Now we'll look at the first group and we'll say what's common. A 2 is common, isn't it? See, this 10 prime factors in the 2 times 5. So there's a common 2. Anything else in the variable form? There's a y, isn't there? What's left?
It's going to be a y.
A y
Y minus 5.
minus 5. Now then,
Plus 7y.
7
I mean, 7x.
x. Yes. And then I have a what?
Y minus 5.
Now what am I going to do?
The y minus 5.
Yeah. When treat those 2 as terms, and I'm going to take a y minus 5 out. And then I'm going to have a what?
2y.
2y plus 7x, right? And that'll be my answer. Let's look at 64. 21x squared plus 6xy minus 49x minus 14y. Polynomial, 4 terms, we're going to try to group. So we group the first 2 terms together. Put a plus and put my signed terms inside the bracket. What's common in the first group? Well, what you can, if you say 21 is 3 times 7 and 6 is 2 times 3, what do you got common? The 3. And then in terms of the variable, an x. Now what's left? First term, 21x, 7x, isn't it? Second one, plus 2y. Now then I go, on these 2 terms, what am I going to do? I'm going to take a minus sign out, aren't I? And then I would do a minus. That plus will change to a minus. And then if you prime factor this, this is 7 squared, and this is 2 times 7. So what's going to come out in terms of the numerical coefficient? A 7's going to come out. Isn't that it?
Yeah.
That's it. So now it becomes what? The first term? A plus 7x, right? I took one of those 7's out. 7. Then the second one is what? Plus 2y. Now then, you see those 2 terms? What do we got? 7x plus 2y. And then we got 3x minus 7. Okay. I'll look at 68. It says 2ar plus a squared minus 2r minus a. 4-term polynomial. Algorithm says try grouping. Group the first 2 terms. Put a plus sign. Put my sign terms inside the second bracket. Look at the first 2 group. First 2 elements in that group. What do we got? Common factor of what?
The first one,
A, isn't it? Common factor of A. What do we have left?
2r minus a.
2r plus A.
Oh, plus a.
I almost fell into your trap. Second one, what am I going to take out? What would make this thing exactly look like that? If I took a negative out, right? Minus, and then I would 2 plus 2r plus a. Now notice these 2 are just exactly alike, so what do I do? Take them out, 2r plus a, and what do I have left? An a here, and what here? Minus 1. And that's completely fine. I'll look at 72. It says 4x squared plus 3xy minus 12y minus 16x. four-term polynomial. Algorithm says group it. 4x squared plus 3xy. Then do a plus, put my sign terms inside. Look at my first group and what's in common there. What's in common? Just an x, right? So I have 4x plus 3y. So, you know, if you look at this and you look at this, what are you going to have to take out? Well, if you don't know, you look at this, you try and factor this. This is 2 squared times 3, right? And then you look at this one as, well, it's easiest if you look at this as, I'll do 2. It's 2 to the what? 4th power? 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 16. Now then, what's common? There's a 2 squared that's common, isn't there? There's a 2 squared here, and then there's 2 to the 4th. So there's a 2 squared, which is 4. And then I'm going to have to take a negative sign out, right? And that's going to leave a 3y. And then this is going to leave a 2 squared with a plus. So that's 4x. So this is x times 4x plus 3y minus 4 times 3y plus 4x. Now is this and this the same? Yeah, they're just commuted addition. So I'm going to take a 4x plus 3y out, and I'm going to have an x minus 4. So that's completely factorable. So you've got to be able to do the problems with that information. Okay. You need to see anything else? All right. Well,